welcome to our YouTube channel. Welcome to AdMaths plus Maths. Okay, we are now moving on to another topic in differentiation, which is how to identify stationary points. So how do we identify stationary points? So we just know first, we just need to understand the definition of what is a stationary point. When you say stationary point, it can be a maximum point or a minimum point. Okay? A stationary point is also called the turning point of a graph. So for example, I have a graph over here. Okay? I have point A and point B are what you call as stationary points, or what you call as turning points, because it is on that point where the curve turns. Okay? And why do we call them stationary points? They are called stationary points because the point where dy over dx is equal to 0 is called, so you see that the derivative of y in terms of x will be equal to 0. So it will be at state. That's why it's called stationary point. Okay? But what kind of point will it be? How will you know that it will be a maximum point or a minimum point? Okay? You will know that it's a maximum point or a minimum point by getting the value of the second derivative. So we are basically now applying two things over here. So before you come into this lesson and watch this video, please click the link below, okay, on the description box. Try to analyze first, what do we really mean by dy over dx and d squared y over dx squared, the first derivative and the second derivative. Okay? So the most important thing that you need to know is how to find out dy over dx and equate the dy over dx is equal to 0. Whatever is the value of the x there, okay, you will get the value of the x. Whatever is the value of the x, put that into the equation of the curve, then you'll get the value of the y to find out the turning point. Okay? Now, to identify if it is a maximum or minimum point, okay, if the value of the turning point, or if the value of the second derivative is less than 0, means negative basically. Less than 0 means negative, correct? If the value of the second derivative, when you change the value of the x, okay, is less than 0, then it is maximum point. When the value of the second derivative is greater than 0, or basically positive, okay, then it is minimum point. I will leave all these things later on while doing the example so that we are guided. Okay? So let's try to do some examples. Oh, by the way, just to explain to you, if you have this one, you notice I colored it with different colors. This part, it's less than 0. So it means the gradient of this is negative. This part, the gradient of this is positive. This part, the gradient of this is negative. Okay? So you notice if you put a tangent, if you put tangents here, so for example at this point, okay, if you put the tangent, okay, it's always negative. This position is always negative. But if I put a tangent on this point, or let's say on this point, let's transfer that here. okay, in this position, so it means it's positive. Okay, also here it will be still negative. So you know that a minimum point will always be on the left is negative and on the right is positive. A maximum point, okay, on the left is negative, or sorry, on the left is positive gradient and on the right is negative gradient. Okay, but remember, turning points, the gradient is always 0. Why 0? You see, this point should not touch anything, so it's a horizontal line. The tangent here is a horizontal line, and when it's horizontal, okay, when you study your straight line graph, okay, when it is a horizontal line, gradient is equal to 0. Okay, when it's a vertical line, gradient does not exist. Okay, so this one also, this point, even if it's a minimum or maximum, gradient is equal to 0. Okay, there. I'll remove this figure already. I hope you understand what do we mean by stationary point. How are we going to identify if it's a maximum or minimum? Okay, let's go to an example so that you better understand this. I'll leave this rule over here. Okay, let's move to the example. Okay, example, find the coordinates of the stationary points on the curve y is equal to x cubed minus 3x plus 1. How do we look for that? Remember, it says dy over dx is equal to 0, okay, is the turning point. Okay, so you need to find out the dy over dx. dy over dx, or the derivative of y in terms of x here, will be 3x squared, okay, minus 3. Okay, so it's 3x squared minus 3. Thus, you will now know that if I equate this to 0, it is equivalent to 0 equals 3x squared minus 3. I'll move negative 3 to the left side. It will become 3 equals 3x squared. I'll divide both sides by 3. So x squared is equal to 1. Thus, you will have two values of x. Why two values? There are two values. One is x equals 1, and another one is x is equal to negative 1. Why are there two values? Because basically, if I square root both sides, okay, this should have a positive and negative value. Okay, so I can remove that. So positive value of square root of 1 is positive 1. Negative value of square root of 1 is negative 1. Thus, I can now find out the points. I already have the values of the x. Now, my problem here is when I say points, it should always be written as, always remember, points are always written as x, y. These are points. Okay, they are always written like this. So, I am not yet complete with finding the points. I need to find out the value of the y. Thus, okay, how can I find out the value of the y? Do I need to use the derivative? Of course not. Why? Because you are, okay, dealing with the curve. Thus, you have to place that x or substitute that x on the curve itself. Okay? So, if x is equal to 1, okay, if x is equal to 1, then therefore, y is equal to 1 cubed minus 3 times 1 plus 1. Thus, y is equal to 1 minus 3 plus 1. 1 minus 3 is negative 2. Negative 2 plus 1 is negative 1. Okay? Let's move this. Next, how if it's negative 1? So it will become y equals negative 1 cubed minus 3 times negative 1 plus 1. Thus, y is equal now to negative 1 cubed is negative 1. Negative 1 plus 3 is 2. 2 plus 1 is 3. Therefore, I have the points 1, negative 1, and another point is negative 1, comma 3. So these are the turning points. Now, how do we know if it is a maximum point or a minimum point? Okay, so that's another problem. Okay, I'll do it with another color so that you will distinguish the first step, second step. Okay, so let's say this is the first step, finding the turning point. Next, finding the identifying or determining the nature. If you are asked to determine the nature means is it a maximum point or a minimum point? That's the thing. Is it a maximum point or a minimum point? Okay? So, if it is a maximum point, then the value of the second derivative, okay, should be less than 0. If it is a minimum point, the value of the second derivative should be greater than 0. Thus, it's very important for us to identify the second derivative. So this is now the application of the second derivative. Okay? So, we have to look for the second derivative. And second derivative is represented by d squared y over dx squared. Okay? So how do you do that? You base and get the derivative of dy over dx, which is 6x itself, which is 6x. That's it. Now, how to find out if this part, okay, point 1, negative 1. Okay, point 1, negative 1 is, we don't know yet. Okay, at point 1, negative 1, I can have now d squared y over dx squared is equal to 6 times 1. Where did I get the 1? There. Where did I get 6 times 1? Because the second derivative is this. Remember, I am getting the value of the second derivative, so that if it is less than 0, then it is a maximum point. If it is greater than 0, then it is a minimum point. Since it is equivalent to 6, what is 6? Is it greater than or less than 0? It's greater than 0. It's a positive number. Therefore, point 1, negative 1 is 1, negative 1 is a minimum point. Okay, it's a minimum point. Next, at point negative 1, 3. Okay, so at point negative 1, 3, I'll have now d squared y over dx squared. Okay, so it will become 6 times negative 1. Thus, it will become negative 6. So, negative 1, 3 is a maximum point. Okay? I hope you understand those two things that we have done. But there's another question here. Sketch the graph of y is equal to x cubed minus 3x plus 1. Okay. You If you can still remember, I have, or you can go back to my videos, I have a lesson on graphing polynomial. Okay, graphing cubic polynomial. You see, it's a cubic polynomial. Okay, this will add up to, okay, this will add up now to your idea on how to graph cubic polynomial. But if you don't know yet how to graph cubic polynomial, I will also put in the link below the description box. Just click that in. Okay. Now, if I am now dealing with this and I am going to sketch that, I'll be using that idea. I'll be using also the turning points. Okay, let's move to that. Okay, I'll remove this. Sketching, by the way, means you should not be using any, although you can use your ruler. Okay, so let's use a ruler. It's just a sketch, so it's not necessarily that you need to become very, very accurate. Okay, so how to sketch that? I'll have to find out the y-intercept. Okay, y-intercept is positive 1, 0. Why positive 1, 0? Y-intercept, I'll make the x 0. So 0, 0. So 0, 0 plus 1 is positive, it's 0, 1. So it means if 1, this is 1, this is 2, this is 3. Okay, this is the y-intercept. Okay, next, I'll have 1, negative 1. 1, negative 1 is here. Okay, let's put that point. Next, I have negative 1, 3. So let's say this is negative 1. Okay, 3 is here. Okay, so I have this point also. Next, my problem now here is I don't have any other points anymore. I cannot just draw like that. Okay, I have to find out the x-intercepts. So let's try to find it out. I'll erase this part already. You know that 1, negative 1 is a minimum point, and negative 1, 3, okay, is a maximum point. Remember, guys, in order for you to do this, you have to factorize that. Okay, how do we factorize? You go and get your calculator, press mode. Okay, exponent is 3. Okay, or the degree is 3. Okay, so let's try to do that in our calculator. So I have here mode equation, degree 3. So I have x cubed, which is 1. Okay, x squared is missing, so 0. Negative 3x, so negative 3, and then 1. I'll get values I'll get values as 1.532. 1.532 is here. This is 2. 1.532 is over here. Negative 1.8. So let's say this is the point. Negative 1.8 is over here. And 0.3. Okay, so it's over here. Okay, remember guys that if it is a positive x cubed, it shapes like this. If it is a cubic polynomial, I'm not saying this is applicable for all. If it is negative x cubed, it shapes like this. Okay? So that's the difference between the two. Okay? Therefore, the graph of this one, okay? Therefore, the graph of this one looks like this. Okay? So it means the graph of this one will be okay. I was able to sketch it as easy as that because I know already the turning points. Okay. I also know the x-intercept and the y-intercept. So as easy as that, you have the graph. I hope you have learned something. Thank you very much and God bless.